Okay, in this video we're going to go through the chain rule and the general power rule. They also start out working with compositions, and the reason why they're doing this is because they are doing the derivative of a composition, and that's kind of a chain rule as well. Okay, so let's get started. So first off, you need to know how to make a composition. So these are two different notations for composition. So I was just going to have you practice finding f of g of x and g of f of x. So this is how you do that. So to find f of g of x, this is what I would recommend that you do. Since f is first, write down the f function. Then wherever you have an x, you're going to replace that with the g of x function. So that means that f of g of x is really going to be 7 times x plus 7 plus 3 more. So that is going to equal 7x plus 7 plus 3. So 7x plus 10. That is your best answer for f of g of x. So now let's do g of f of x. So g of f of x, since g comes first, write down the g of x function, which is x plus 1. Once again, any x's you have, box them off and replace that x with your f of x function. So therefore, my function is going to become 7x plus 3 plus 1 more. And so the best form is going to be 7x plus 4. So that's just a review on compositions. So then the textbook goes into this other little piece, and they call it decomposing a composition. So what they're doing is they want you to think of the f of x as the outside function. And then they want you to think of the g of x as the inside function. So if they ask you to find f of x and g of x, f of x is going to be the outside, which is just the square root of x. And what I should do, let me just change colors on this. So hold on. So I want to do f of x in pink just to be consistent. Okay, so f of x is going to be radical x. Okay, and then what's g of x? Well, g of x will be the inside, which is x plus 7. So we have decomposed the composition into its two parts. Okay, h of x, the outside, which is the f of x, is going to be x cubed. And then the inside is going to be 2x squared plus 1. Okay, so this is going to be your g of x. These are all going to be your f of x. Okay, so let's go on to the next page. Okay, so here they're saying taking the derivative of a composition using the chain rule. So to differentiate this composition, first what they want you to do is differentiate the outside function. That would be the f of x. Then you're going to substitute the g of x in for the x in the result. Then multiply by the derivative of the inside function. So here, take the derivative of your x, replace all your x's with g of x, and then multiply that by the derivative of the g of x function. All right, so let's practice doing that. So if my f of x is x to the 4, they want me to take that derivative first. So I'm looking for the derivative with respect to x of f of g of x. So that's going to be 4x cubed, but what do I have to do? I have to replace this with my g of x. So I'm going to really write 4 times 3x plus 2 cubed. Okay? And then multiply that by the derivative of the g of x, which is 3. So your derivative actually equals 12 3x plus 2 cubed. Okay? So that is the derivative of the composition. Now notice, I never actually built the composition, but by following this chain rule, and this is this and this, you can take the derivative of that composition. And that's the way I want you to do derivatives of compositions. Okay? So then there's another topic, and it's finding the derivative of a function that is not specified, and we're going to find it using the chain rule, and that's on the next page. So let's look at that. So notice, they want us to find dy dx. Well, y is a function of u, and u is a function of x, so there is no y as a function of x. So we're going to use this chain rule. So look what they're doing. Dy dx equals dy du times du dx. So this is the chain rule, and then you have to always remember, okay, all will be in terms of x. So you can only have x in your answer. You can't have u's, you can't have y's. You can only have x. Okay, so let's try to do this following the chain rule. Okay, so I want to find dy dx. So they tell us, first find dy du. So dy du is going to be 5u to the 4th minus 6u squared. Now, these u's are going to have to go. So I'm going to just box them off for a second because we're not quite done. So this is the first part of the chain. Now let's do the second part of the chain. So the second part is to find du dx. So that's going to be just 2x. Okay, so let's clean everything up, bring them all together. This is what I'm getting. So I'm going to say 5 times, instead of u, remember you're finding dy dx, so you can only have x's in here. So replace that with your u value, written in terms of x, raise it to the 4th, minus, and then we have 6 times x squared plus 1 squared, and then this entire thing is multiplied by 2x. Okay, and that's your dy dx. Because notice that you only have x's, and that's what you want. Okay, here's a second one to practice. So it says find dy dx if y equals u cubed plus 4u squared plus 7u, and u equals x cubed plus 3. Okay, so I don't really have y as a function of x, but I do have dy du, and I can multiply that by du dx, and then think about kind of canceling like this. You don't actually do that, but you can see how dy dx jumps out at you. So let's build our dy dx. So dy dx is going to equal, by our chain rule, dy du, which is 3u squared plus 8u plus 7. Okay, and don't forget, these guys are going to be switched out by this expression right here. But we can do that in a second. So this is going to be multiplied by du dx, which is going to be 3x squared. So now let's clean this up. So the correct final answer is 3 times, replace the u with x cubed plus 3, that's going to be squared, plus 8 times x cubed plus 3 plus a 7, and then all of this is multiplied by 3x squared. And that is your best answer for dy dx. Okay, so I think I'm going to do the marginal revenue on the next page. Okay, so this is another application of a chain rule. So I need to find dr dt, and dr dt is going to equal dr dx times dx dt. So let's see why. So this says a store sells ties for $12 a piece. Let X be the number of ties sold in one day, and let R be the revenue received from the sale of X ties, so that R equals 12X. Okay, so this is the first function. R equals 12X. Suppose that daily sales are rising at a rate of 4 ties per day. Okay, so I'm going to call that, let's call that X. So, let me just see this. Well, yeah, we're not going to call that X. We're going to call the rate of 4 times per day, what is that? That is dx dt already. That equals 4. All right, so how do I figure out at what rate the revenue is changing with time? Well, look what I'm going to do. What's your dr dx? Well, that's going to be 12 just looking at this function. And what is your dx dt? Well, they told us in a sentence that it's 4. So dr dt is going to be $48 per day. Okay, let's try another one. What if a store sells Timex watches for $20 per watch so that the revenue equals 20 times X? If the quantity of watches sold is reduced by 2 per day, okay, the watch is the X, so dx dt equals -2. How fast is the revenue changing? So they mean how fast with respect to time. So dr dt is going to equal dr dx, which is right here, and dr dx is 20 times dx dt, which is -2. So your revenue is falling by $40 per day. Okay, and with this information, you should be able to do the 3.2 problems. Just keep looking back at this, because sometimes the chain rule is a little confusing at first, and you have it all documented right here.